Hello everyone, this is the first lesson recording for IM1, March 26, 2021. Time for a new pet? Well, this is the tiniest chameleon discovered in northern Madagascar, and it's measuring just at 28.9 millimeters, which is believed to be the smallest reptile on Earth. So it's like the width of your finger. Pretty small. Announcements. Monday, Tuesday, Wednesday you're going to be following outreach schedule. That means there will be no synchronous class meetings on both Monday and Tuesday. So usually Monday is a A day and Tuesday is a B day. You're not going to have either of those classes on Monday and Tuesday. It is so that the teachers will have time to set up for hybrid learning once the spring break is over. I believe that's the rationale. Anyway, so that means I will not be seeing you on Tuesday. However, the homework 21 that is assigned today is still going to be due on Monday, and you are going to be assigned a classwork. It's going to be a review work to prepare you for the unit test that is happening on the following Friday. Okay, so it is really important that you do spend the time wisely so that you will do well. Remember, there are no retakes on unit tests. Quiz number 4. We're going to go over some of the questions and answers during class today, and the retake will be available for today at 3 p.m. Those of you who are interested in going through it. As I have said, next Friday, so 1 week from today, is going to be the unit test. And it's going to be material from quiz number 4 that we are going to go over. Some of you did not do well, so hopefully you are going to be listening well when we go over the questions together so that you can do the retake and you can improve your grade. And that is also going to be helping you to prepare for the Unit 5 test. And the new material that's going to be in there is the inequalities. And we will also have some questions on solving equation, multiplying polynomial, and exponents. There will be extra study hall on Wednesday. That's the cohort day from 12 o'clock noon to 1 p.m. to answer any questions you might have in preparation for the unit test. Okay, and so the review packet that is going to be assigned to you on Tuesday, well, it will probably be available for you on Monday if you are interested. The answer worked out solution key will be available for you to look at my solutions on Wednesday, probably Wednesday afternoon, because I really do want to give you a chance to try the problems on your own. So do check the answer key, the worked out solution that is going to be published. I would also like you to take a quick survey on the hybrid learning, what your options are and what you are choosing, and so on and so forth. It won't take long, so if you can take the survey, I would really appreciate that. So what are we doing today? We are going to reinforce concepts we've been learning so far to prepare for the test, and we're going to be doing some review of inequalities, absolute value functions, and exponentials. So to get us started, I would like you to tell me in private chat, if I have this phrase, to be able to drive, you must be at least 16 years old. If I say that, what is the inequality that I am interested in? Is it A, x is greater than 16, x is less than 16, x is greater than or equal to 16, or x is less than or equal to 16? I would like you to tell me in private chat. Well, let's think about this logically. You must be at least 16. Does that mean that if you're 16, then you can drive? Yeah, at least means you can be 16 and you're still allowed to drive. Okay? Does that mean that if you are 15, you're allowed to drive? Well, at least means at the minimum, you need to be 16. Okay, so 15 will not do. 16 would do and 17 would do. That means you need to be 16 or older. So you can be 16 or bigger than 16. So it is going to be C. What about this phrase? You can win at most $30. At most. What does at most mean? That means no more than $30, right? Can you win $30? Yes, you can, right? So that means what is the inequality that we are interested in? Well, we know that what you're going to be earning is $30, but no more. So at most means no more. So it's going to be less than 30, or it can also be equal to 30. So the correct inequality would be D, and is less than or equal to $30. All right, now let's talk about this. This is from one of the quiz problems, okay? If Tom's salary increases by $600 each year, is this a linear situation or exponential situation? Okay, so let's think about that. Okay, so each year, we can just quickly draw a table. Okay, so let's just say in year 0, this is year, and that's the salary. Let's just say in year 0, he starts off with $1,000. Okay, and it increases by $600 each year. That means the next year it's going to be $600 more, so it's going to be $1,600. In second year it's going to be $2,200, because we are increasing, we are adding $600 each year. Okay, when we add, is this linear or exponential? Okay, when we're adding the same amount, we have a common difference, don't we? We're adding 600 each time. So it is arithmetic sequence, or it is a linear situation. It's a linear situation where each year, as the year changes, what the value of salary that is changing is 600. Okay, so the slope or unit rate is 600. In this case, what is the initial value? The initial value is 1,000. Okay, so what is the equation in this case? It will be 1,000 plus 600 times x, or you might have seen it as mx plus b, so 600x. Unit rate, or the common difference, is 600, and the initial value is 1,000. Okay, so this is a linear situation. Okay, what about this? If the Tom's salary increases by 6% each year, let's just assume that the initial salary was $1,000 again. If Tom's salary increased by 6% each year, what would your table be like? Whoops, I'm sorry. What would your table be like? Well, in this case, in year 0, let's just assume the salary was 1,000. What would be the next year's salary? Well, it's increasing by 6%. So what are we going to be multiplying by to get to the next value? Well, we can do it two different ways. We can figure out what is the increase. What is 6% of $1,000? Well, 1% is going to be $10, so 6% is going to be $60. So we are adding $60 to $1,000, so that's going to be $1,060. Okay, but with this $60 we calculated was 6% of $1,000 was $60. That's why we added it. Are we going to add another $60? No, because what we are doing is we are multiplying. What do we multiply from to 1,000 to get 1,060? and 60, we actually multiply by 1.06. Okay, and we got the 6%, the 06 from 6%, and we need to add the original amount. So that's where the whole 1 comes from. So you're multiplying by 1.06. So 6% goes here, and the fact that you are adding the original amount is the 1. So that's where you get the 1.06. And again, to get to the next year, you're going to multiply by 1.06. Okay, remember that exponential growth with percentage, we had the equation y is equal to a times 1 plus r to the power of x, where r was the percentage converted into decimal. So in this case, 6% converted to decimal is 0.06. 0.06 plus 1 is going to be 1.06. So the multiplier that we are multiplying is 1.06. And A is the initial value, which is 1000. So the equation for this situation would be y is equal to 1000 times 1.06 to the power of x. Okay, so we're given this equation, okay, exponential growth or decay. Well, first of all, what is the multiplier? What is the number that you keep multiplying by? The multiplier is 0.7, okay? So the multiplier is less than 1. So are the numbers going to get bigger or smaller? Remember, when the multiplier is bigger than 1, the numbers are going to be increasing, so it's going to be exponential growth. However, when the multiplier is less than 1, then the numbers are going to be decreasing as you multiply 0.7 over and over and over again. Okay, so it's going to create a decay. So we know that this is a decay problem, something that is going to be going down in value. Okay, so what does this look like? Remember, the equation percentage increase and decrease was going to be 40a to the power of 1 plus r if it's growth to the power of x, or y is equal to a times 1 minus r if it is a decay. Okay, and it is a decay, so the number is going to be less than 1, and so this is decay, and we know that this number is the multiplier. So something is decreasing by 30% or 0.3, because the only way I can get 0.7 is if r was 0.3, which is same as 30%. So something is either decreasing by 30%, or it is the 70% of the original value. So you're multiplying by 70%, or it's decreasing by 30%. So if you have choices between this, okay, so the options were the soccer ball started at height of 45 inches. Each bounce is 70% of the previous height. The soccer ball, remember, the general formula for exponential growth or decay is a times b to the power of x. A is my initial value, that's 45 inches. And the multiplier is 0.7. That's the number that you're multiplying to the initial value over and over and over again to get the next number. And so 0.7 is same as 70%, so that would be consistent with this equation. The average temperature was 45 degrees in 1990 and has been increasing by 0.7 degrees each decade. Okay, if it is increasing by 0.7 degrees each decade, that means we are increasing 0.7 degrees each 10 years. So we are adding the same 0.7 degrees every 10 years. So this is not exponential. This is linear. And this is loses 0.7 height each year. So this is